The natural world is amazingly complex. The richness of species across ecosystems is both inspiring and essential. Biodiversity provides the basic services that make life on Earth possible. But alarmingly, wildlife population sizes have dropped a significant 68% since 1970. This dramatic loss is mainly caused by habitat destruction and climate change. More worrying, future scenarios indicate that biodiversity will continue to decline over the 21st century. Taking immediate action to halt and reverse these trends is absolutely necessary. Frogs are a good indicator of biological diversity and ecosystem health. If we can understand the spatial distribution and the environmental and climatic drivers that support frog species, we can work towards biodiversity preservation and restoration.
Sure. DEY Building a Better Working World Challenge task participants with this problem. We are excited to participate and contribute to such meaningful challenge. The goal is to develop a multi-species distribution model of frogs using climatic and environmental predictors. We have information of the occurrences of 9 species of frog in 3 countries. Some species are more common than the other. Based on location where frogs were observed, we downloaded data on climate, land use, surface water, elevation, and vegetation. Importantly, we consider monthly variation in these predictors to account for seasonalities in the frog life cycle. So, can environmental conditions predict frog occurrences? As a team, we worked hard to build a mathematical framework that is able to evaluate the importance of environmental conditions to predict the occurrences of the 9 frog species.
We use a multinomial logistic regression model. This model estimates the probability of occurrence for each frog species at a given location using the environmental conditions of that place. We use multiple steps, shown here, to select model predictors. Our model identifies 11 easily interpretable and actionable predictors of frog occurrence. We identify specific months of the year when the predictors are relevant. Here, we reported the importance plot of each predictor. Precipitation in October and November are likely to be the most relevant variables that increase our model performance, represented by the F1 score. Most of our model predictors show variation across species, suggesting that conservation efforts need to be localized and species-specific. This is illustrated in the figure on the left. In the figure on the right, we show our probabilistic model output for the submission points. Although our model does not rely on any spatial information, it is able to distinguish between frog species specific to each country.
What makes our approach the best? What are the characteristics that make it unique? Our model has 3 key benefits. First, our framework is biologically realistic. We include monthly predictors to account for seasonality in frog life cycle. Second, our model is parsimonious, having high predictive power, using only 11 interpretable predictors. Lastly, our model is a multi-species global discovery tool. It can identify important commonalities and differences in habitat suitability across the different species. How can our model help fight biodiversity loss and improve ecosystem health? Identifying the drivers of suitable frog habitat can inform policy and sustainable management strategies. For example, the information provided by our model can support the conservation of existing frog habitats and the restoration of degraded ecosystems. As we enter a new era of global change, tools like ours can be used to preserve and promote life and all its amazing diversity.